The next approach for non-parametric distribution is splicing, where we look at different ranges and come up with splice points. So here you visually examine and you say that the first distribution goes up to about somewhere between 30 and 40. Okay. And then the next splice point, so here we're going to try to fit one distribution like that, and then one like that, and then one like that. So the break points or splice points somewhere around about 35, and then one about 45. Okay, so we come up with this on our own. So it's we examine the actual data, and then see we can use one of the actual data. So we have 34.3 and 43 as the two splice point. So that will give us 3 distributions. Okay. So what we need to do is okay. So we have to find the best fit for those 3 ranges. The first range is 34.3 below 34.3, and then, well, greater than or equal to 34.3, less than 43, and then greater than 43. So let's start with the first one. So start from here, 34.3. So it's probably easier to search for 34.3. Okay, and it's less than 34.3. Okay, so there we got 34.3. So we will not include 34.3. So up to 34.2. Okay, move up, and now we have highlighted the data and do a fit. Okay, so we have a normal distribution that's fit for this range of the data. So write to Excel. So that will go here. So that's the first one. Okay. The second one is we need to go up to 43. So we know 34.3 is over here. Okay, and then let's highlight from here 43, right? Okay, so not including 43, so there you go. Now again fit. This one happens to be triangle. Okay, so write to Excel. So that will go here. Okay. So now the last one, 43 and greater. So I'm going to search for 43. All right, close that. So we have 43 and on the rest of it. So now fit. Okay, now this one is exterior value min. Okay, so again, write to Excel. So that's the third one right there. Okay, so now we have 3 distributions that we have fit. Okay. Now we need to splice them together. So the way we're going to do is we're going to splice the first one and the second one. So that will give us 1 plus 2. And then we take 1 plus 2 and splice it together with 3. So that will give you 1 plus 2 plus 3. So first spliced distribution. Okay, so we have to do risk splice. Go to function. Okay. Now risk splice is it's a special function. So you go to function, special, and select risk splice. Function, special, risk splice. So you have to say where are the which two distributions you want to splice together. So that one with that one. Okay, and where should the two come together? That's your splice point. So that's your first splice point. Okay. So now this one is a combination of 1 and 2. Now we take that and splice it together with the third one. So special splice. So the first one is the spliced distribution. The second one is that. And now the splice point is 43 there. Okay. So now we have the spliced distribution. So the two that there are 3 of them that we are considering. One is just the best fit from at risk. The second is non-parametric risk cumulative, where we fit the data and come up with a cumulative probability distribution. And then we have the risk spliced distribution. Okay. Okay. So for the spliced distribution, we have that as the output. Okay, and the mean. Okay, so now we have risk mean of that. Okay, so let's make that an output cell. And these two also as output cells. Okay, range name is that. Okay, range name is best fit and non-param. Okay. let's say average MPG with best fit, and average MPG with risk cumul. Okay. So this will be risk mean of that, and we can just copy that down, so it will be the risk mean of the next value. Alright, so now we are ready to simulate. Okay, go to settings, make sure that multiple CPU is enabled, and let's do a fixed random seed. Alright, now simulate. Okay, so the best fit was the triangular distribution, so you get triangular distribution. And let's add overlay of non-parametric, and you see non-parametric resembles very closely to our data, and let's add another overlay of that one, and that one again, because it is parametric distributions stuck together, it's not exactly the same. See, like the non-parametric one was very, very close to the data, whereas this one is not. So that's both an advantage and a disadvantage, because if you are too granular and you start fitting the exact data, then you get the exact data back. So you're not doing any. So the simulation is just for that one particular data set. So here risk cumulative, so simulate the data more closely, right? So the more the percentiles used, the simulated values the simulated values more closely resembles the data, can only simulate what is observed in the data. So that's a that's the disadvantage. So data may have very few or no observations in the tail, so you don't capture the tail, which is probably the most risky part of the model, so we are not capturing that. Whereas this splice, parametric distributions, they are spliced together, well, not sliced together, spliced together. And parametric distributions can simulate values that are not present in the data, so because we're using parametric distributions, and the splice distribution simulate data in the tail as well, but it is still a parametric distribution. If it fits your data well, that's good. Otherwise, you may have to fall back on risk cumulative. But you need to know the pitfalls and the advantages of each to make a informed judgment as to which one of these two methods you want to use.